In this video, we are going to work the following problem. So we want to find the intervals on which f is concave up and concave down. And f of x equals x to the 7th over 6 minus x to the 6th plus 4x plus 3. Okay, so the first thing we want to do is to find the domain of f, which is easy because it is a polynomial. And the domain of any polynomial is all real numbers. Next up, we want to take the derivative. So all we have to do to take the derivative of this polynomial is to take the derivative of each term, right, and then subtract or add them as whatever the case may be. All right, so this first term here is x to the 7th over 6. You can also treat that as 1/6 times x to the 7th, which is what I'm going to do, because then I can use the constant multiple rule instead of the quotient rule. All right, so the constant multiple rule says to rewrite the constant and multiply by the derivative of x to the 7th. So that's going to be 7x to the 6th using the power rule. Then subtract off the derivative of x to the 6th using the power rule. That's going to be 6x to the 5th. Then add the derivative of 4x, which is 4. Okay, so just cleaning that up a little bit, I get that the derivative is 7/6 x to the 6th minus 6x to the 5th plus 4. All right, and the domain of the derivative is, again, all real numbers because it's a polynomial, and the domain of any polynomial is all real numbers. All right, next up, I need to take the second derivative, right, because I am after the intervals on which the original function f is concave up and concave down. So taking the derivative again. So using the constant multiple rule on this term, I'm going to rewrite the constant and multiply by the derivative of x to the 6th, which is 6x to the 5th. Then, again, using the constant multiple rule, I'm going to take the derivative of this term, so that's going to be 6 times 5x to the 4th. And the derivative of 4 by itself is 0, so I'm not going to bother to write the plus 0. All right, so simplifying that out, we get 7x to the 5th minus 30x to the 4th for the second derivative. Okay, so what we're going to do then is we want to solve the inequality f double prime of x greater than 0. That's going to tell us where the original function f, the intervals on which it is concave up, and also in the process of solving this, we'll also be able to figure out what the intervals on which it's concave down. So we need to solve this inequality, 7x to the 5th minus 30x to the 4th greater than 0. That is a polynomial inequality, so what you want to do is to set it equal to 0. And solve that out. To solve this polynomial equation, what I'm going to do is factor out the greatest common factor. So when I do that, I get an x to the 4th, and so that would leave me with 7x minus 30 equals 0. Okay. And then I would set each of those factors equal to 0 and solve those out. All right, so solving out each of those All right, so solving this first one, x to the fourth equals 0. The only way that that x, any number raised to the fourth power, could come out to be 0 is if x itself were 0. And then solving this, I would get 30 over 7. So these are my possible critical numbers of f prime. All right, what you want to do is to take those possible critical numbers of f prime and put them on a number line representing the domain of the second derivative. And the second derivative is a polynomial, right? So its domain is all real numbers. All right, and put those numbers on a number line. All right, at this point, it is a good idea to classify these as being critical numbers of f prime or not. All right, and that depends on whether or not they are in the domain of f prime. Here, right, the domain is everything, so these are both critical numbers of f prime, and that's important because to identify those, because the critical numbers of f prime are the possible inflection points of the original function, or the possible x values of possible inflection points. Okay. All right, so those possible critical numbers of f prime are going to divide the number line up into a number of pieces. In this case, right, there's 3 pieces. And what you need to do is to pick a number on each piece, right, and plug those into the inequality that we're trying to solve. So 37ths, that's 4 point something, right? So I would know that 5 is on that piece, 1 would be on this piece, and -1 would be on this piece here. So what I'm going to do is to take those numbers and plug them into this inequality here. Okay. All right, so plugging in the 1, or the -1, let's start with that one. When I plug in the -1, I am going to get -7 minus 30. So I get -37 greater than 0. All right, and so I get a negative number here. So what that means is that on this interval here, the one that's to the left of 0, that whenever I plug any of these numbers into the second derivative, I'm going to get a negative number. Okay? Because remember, it's all or nothing on each piece, right? And when we plugged in the -1, we got that a false statement, -37 is not greater than 0. So that means that -1 is not a solution. That means no number on this is a solution, right, to this inequality. So what that means is if I take any number in here and plug it, it can't be greater than 0. So it has to be less than 0, since we already found all the places where it's equal to 0. Okay. All right, next up we will plug in this value for 1 into the same inequality. So we would plug that in, and we would get 7 minus 30 greater than 0. So you get -23 greater than 0. So again, we get a negative number, so we will put a minus sign over this interval. What that means is that every number, when we plug it in, right, we will get a negative number there. All right, so Last one is this 5. We need to plug that into the inequality. All right, when I do that, rather than try to do these larger numbers in my head, I am going to use this factored format, right? Over here. Again, when you use this factored form, make sure that it's exactly the same as what you started with over here. It has to be exactly the same, so it's easy to mess that up if you're not very careful about that part. If you have a calculator, you can just plug it in there and not worry about it, but it's just a little awkward to do on video. So I'm just going to take this 5 and plug it in here. So I have 5 to the 4th. 7 times 5 minus 30 greater than 0. So when I do that, I get 5 to the 4th, and 7 times 5 is 30. 35 minus 30 is 5, and so I get that. And so 5 to the 5th, all I really care about is that I know that that's a positive number. Okay. And so again, going through all that stuff, that means that 5 is a solution, right, to this inequality. It means that every number is a solution on this piece to the right of 37ths is a solution. Okay, and so therefore that means that if I take any number on that piece and plug it into the second derivative, I will get a positive number. So I'm just going to label that interval with a big plus over the top. Okay. All right, so now my sign diagram is complete. And so I can answer this question. So the question is, on what intervals is f concave up? On what intervals is f concave down? So f is going to be concave up on the intervals where there is a plus. And that is this interval right here, 37ths to infinity. F is going to be concave down on the intervals where there is a negative. So that would be this piece over here to the left of 0, and this piece over here in between 0 and 37ths. All right, and that is it on this problem.